My dear students, today's lesson is solubility of silver halides. In this lesson, the points to be discussed are solubility, like dissolves like, solubility of silver halides, and finally mechanism of solubility. So let's begin. The very first point is solubility. Now let's see what is solubility and which substances are soluble in which substances. Let's consider this is a glass with water and it is 250 milliliter, and here salt sodium chloride is added, that is 10 gram. Another glass with water 250 milliliter, and here oil or fats or oils is added, this is 10 gram. Now let's see, first of all, mixture. Mixture is defined as the substance made by mixing two or more substances. So this is a mixture of salt and water. This is mixture of oil and water. So mixture is defined as the substance made by mixing two or more substances. This is the mixture where composition is uniform. In every place the ratio of the components is same. That means this mixture is called a homogeneous mixture. And here oil floats on the surface of the water. This is not homogeneous mixture. In this case, composition is not uniform throughout the mixture. In this case, composition is uniform throughout the mixture, and in this case, composition is not uniform throughout the mixture. Based on this point, this is called homogeneous mixture, this is called heterogeneous mixture, and this homogeneous mixture is called solution. The definition of solution is a liquid mixture in which composition is uniform throughout the mixture. This liquid mixture is called solution. And in this case, sodium chloride is minor component. That means this is only 10 gram. But water is 250 milliliter. This is a major component. So in the solution, the minor component, that is less in amount, this is called solute, and the major component, that is more in amount, that is called solvent. So here salt is solute and water is solvent, and solution the mixture in which composition is uniform. That means solute dissolves completely in the solvent, that is called solution. Now the solubility. Sodium chloride mixes here with water completely, but in this case oil doesn't mix with water at all. So this matter is called solubility, and solubility is defined as the ability of a substance to mix with other substance completely. This is called solubility. Different substances have different capability to dissolve with other substances. This is explained with a proverb, like dissolves like. Now let's see what is like dissolves like. The point is now, like dissolves like, meaning is polar solute dissolves in polar solvent. Now let's see some polar compounds, that is ACl is a kind of polar compounds, then sugar, sodium chloride, these are polar compounds, and water is a kind of polar compound. Let's see how this is polar. Here the electronegativity of chlorine is 3.0 and hydrogen is 2.5. Electron cloud, that means covalently bonded electrons, move towards chlorine. That is why it gets partially negatively charged and it becomes partially positively charged. So there are two poles, negative pole and positive pole. So this is a polar compound. Again, let's see water. This is negatively charged and it becomes positively charged because electronegativity of oxygen is 3.5 and hydrogen is 2.1. So electron cloud shifts towards oxygen, and that is why oxygen becomes negatively charged and hydrogen becomes positively charged. So this is also a polar compound. And sugar, there are some OH groups in sugar molecule, and this is also polar. This is minus, this is plus. So sugar is polar compound. Then let's see sodium chloride. Sodium chloride is a kind of ionic compound and it acts as polar molecule. Now when any of the compound, suppose sodium chloride, is dissolved in water, then water dissolves sodium chloride in it. This is called like dissolves like. That means polar solute dissolves in polar solvent. Here these are polar solutes: hydrogen chloride, sugar, sodium chloride, and water is polar solvent. Water is called universal solvent because of its high capability to dissolve many kinds of substances in it. That is why water is called universal solvent. So this is about polar solute dissolves in polar solvent. Now let's see nonpolar solute dissolves in nonpolar solvent. Like polar compounds dissolve in polar solvent, similarly nonpolar compounds dissolve in nonpolar solvent. Now let's see what are nonpolar compounds. Fats or oils are nonpolar compounds. Then grease, wax, benzene, carbon tetrachloride, ether. These are nonpolar compounds. In this case, fats and oils, that is the general formula of fats and oils is this. This is the general formula of fats and oils. Its name is triglyceride. This is a kind of nonpolar compound because the major part of this compound is alkyl group, which is a bulky group, nonpolar group. Hydrocarbon groups are nonpolar groups, and the major part of this compound is alkyl group, nonpolar hydrocarbon group. And there is a little chance to be polar here, that means carbonyl group, and in this case it gets positively charged, but alkyl group is electron donating group. Ultimately this charge is vanished and the molecule becomes completely nonpolar molecule. And another one is grease, hydrocarbon, which is nonpolar, wax, nonpolar, benzene, nonpolar, carbon tetrachloride. This is carbon tetrachloride, electronegativity of chlorine is greater than carbon, but the dipole moment of this compound is 0 dB. So this is also non-polar compound. Another one is ether, diethyl ether. This is also non-polar. Electronegativity of oxygen is greater, but here the dipole moment of this compound is 0 dB. So these compounds are non-polar compounds, and for this reason, when fats or oils are dissolved in benzene or carbon tetrachloride or ether, then these compounds will dissolve in these solvents like benzene, carbon tetrachloride. This is called like dissolves like. That means non-polar solute will dissolve in non-polar solvents and polar solutes will dissolve in polar solvents. The mechanism will be showed in the last point of this lesson. Now let's see the solubility of silver halides. Now the point is solubility of silver halides. That means we have to determine whether silver halide is polar or non-polar compound. Here X is the symbol of halogens. Now let's see the halogens: fluorine, chlorine, bromine, iodine and astatine. This is a radioactive element, so it is kept out of consideration. And the halide ions are fluoride ion, chloride ion, bromide ion and iodide ion. We know from top to bottom along a column in the periodic table, atomic sizes increase, and at the same time anionic sizes increase as well. Now we can write the order of atomic sizes or order of anionic sizes. Sizes is iodide ion, chloride ion, bromide ion and then fluoride ion. That means iodide ion, its size is the most and the size of the fluoride ion is the least. Now let's see the silver halides, that is silver fluoride, silver chloride, silver bromide and silver iodide. Actually these halides are ionic compounds. But due to polarization, some get covalent character and some do not get covalent character. Now let's see how silver iodide gets covalent character and silver fluoride cannot get covalent character. Now let's see the molecular structure of silver fluoride. This is silver and this is fluoride ion. This is electron cloud. Silver and fluoride ion. This is silver iodide, silver plus, and this is iodide minus, and this is electron cloud. Iodide, which is bigger in size, and fluoride, which is smaller in size. Now let's see here, this is the atomic size and this is electron cloud. So the distance between nucleus and electron cloud is comparatively shorter distance than the distance between nucleus and electron cloud in case of iodide ion. This is silver iodide. So here in case of iodide, the distance between nucleus and electron cloud is more compared to the distance between nucleus and electron cloud of fluoride ion, and as a result This electron cloud is bonded to the nucleus loosely, and here this electron cloud is strongly bonded to the nucleus, and as a consequence this cation attracts this electron cloud, and electron cloud comes here on a large scale. That means polarization happens here on a large scale. But in this case, this electron cloud is strongly bonded to the nucleus. That is why polarization happens on a limited scale, extremely limited scale. We can say here polarization is the least. That means this compound remains as it is, almost as it is. That means ionic compound. And here this compound turns into covalent compound. This charge is diminished or vanished. When electrons come here, this charge and this charge, both the charges are diminished and the compound gets covalent character. So this is the way, that means through polarization, silver iodide gets covalent character, and due to the no polarization, almost no polarization, it remains as it is. That means it remains ionic in character. Now, according to the like dissolves like, the ionic compound, that means silver fluoride, which is ionic in nature, that is dissolved in water. This is ionic compound, that means it acts as polar molecule, and this is polar compound. So it dissolves in water. But silver iodide through polarization gets covalent character. It turns into covalent compound. That is why it doesn't dissolve in the polar molecule. This is non-polar molecule, this is polar molecule. So non-polar molecule will not dissolve in polar molecule. So this is the solubility of silver halides. That means it dissolves in water on a large scale, then it dissolves on a limited scale, then it is on a limited scale, and it is almost not soluble in water. So this is the solubility of silver halides. That means the order of solubility is silver fluoride, this is soluble, and solubility is decreased like this, silver chloride, then silver bromide, and then silver iodide. That means this is soluble and silver iodide is insoluble in water. Now let's see the mechanism of solubility of silver halides. Now the point is mechanism of solubility of silver halides. We learned that silver fluoride is soluble in water and silver iodide is not soluble in water, because through polarization it gets covalent character, and here polarization doesn't happen because of the smaller size of fluoride ion. It remains ionic compound, and that is why it dissolves in water and it doesn't dissolve in water. Now let's see how silver fluoride dissolves in water. This is ionic compound silver fluoride, and this is the water molecule. This is plus and this is minus. So this cation is attracted by the negative end of water like this. minus, plus, here plus, and this negative ion is attracted by the positive end of water. Minus, plus, plus. This is the attraction. Here this is the attraction. At one stage, the attraction between silver ion and fluoride ion is broken, and silver ion is surrounded by some water molecules, and fluoride ion is surrounded by some water molecules like this. Silver ion, water, this is the negative end of water, this is water, this is also water, and fluoride ion is surrounded by some the water molecules like this. Water, water. So in this way, silver fluoride dissolves in water, but since there is no positive and negative charge on silver iodide, that is why in this way, following this mechanism, silver iodide doesn't dissolve in water. This is all about the solubility of silver halides. In short, silver fluoride, which is ionic in character, dissolves in water, and silver iodide, which gets covalent character, doesn't dissolve in water. Now today, thank you very much.